Welcome to Byte-Size Data Science. If someone tells you there were 175 accidents in Chicago yesterday, what do you say to that? Is it good news or bad news? Obviously, you don't know. There is some context missing. We need to know more about what usually happens in Chicago. This is where time series comes in. Data that varies over time is referred to as time series. Why should you care? Let's take a look at some examples. The example most people are familiar with is stock price. An entire industry revolves around that. We see the price of the stock change constantly. In medicine, we see time series everywhere. It includes the monitoring of heart rates, oxygen level, and so on. It also includes monitoring the changes of patients' condition over time. For example, aortic aneurysms are monitored over time to gauge the speed of the progression and decide when an operation is required. Weather prediction relies on time series. With this, we can estimate when a storm will hit or when a tornado will touch down. What about how a restaurant can estimate the amount of food to prepare for the day? This depends on information like how many customers were there the previous days or the same weekday on the last few weeks. We can see examples in many other places, such as sales forecasting and product ordering. What about preventive maintenance? Any company that has equipment needs to optimize their use, from a fleet of cars and trucks to manufacturing machinery. This also applies to utility companies that are required to maintain power lines and transformers. We can also say that the majority of data is time-based. A lot of modeling is based on data from a snapshot in time. We can get additional insights when we treat this data as time series. Time series are an important type of data to analyze. Let's look at some of their characteristics. Time series can be regular or irregular. Regular time series have data that follow a regular interval. For example, it could be a set of daily values. That does not mean that the data is collected every day of the week. It could be data collected only on weekdays. This way, we would have 5 readings per week. This introduces a concept of calendar for regular time series. The calendar could be more complex and include some additional restrictions such as holidays. Irregular time series include readings that are at irregular intervals. Let's say we have a sensor that monitors if a door is open or closed. One reading is collected when the door is opened. No other readings is collected until the door is closed. The door could stay closed for hours, then be open for a few seconds before being closed again. We can then assume that the state of the door is the same until the new reading is found. An irregular time series could be converted into a regular one. Let's take a well-known example, stock price. The price of stock changes irregularly throughout the day. We can convert this to a daily time series that will include an opening price, a closing price, high and low of the day, volume, and so on. This way, we have a regular time series and still have a lot of information on what occurred during the day. This can be seen as removing the distractions of a fluctuation throughout the day to be able to do better analysis and modeling. A time series may have one variable and is then called univariate. If multiple variables are part of each reading, it is then called multivariates. There is one more characteristic I want to mention. A time series can be stationary, like it should be in the case of sensor monitoring for equipment. It can also be non-stationary, like in the case of the stock market that has tendency to go up. The stationarity of a time series impacts its analysis, as we'll see in future videos. See you next time on Byte-Size Data Science, and don't forget to subscribe.